Hello, everyone. Welcome to week five's Godot workshop. And this week, we're going to talk about finite state machines. All right. And actually, this is not the physical session on Thursday. And I'm actually recording this session on Friday because I forgot to press the record button again. But I know some of you weren't there yesterday because you were in the SGJ Drink Up session and couldn't make it to our workshop session. So I decided to just record one more session for those of you who would like to learn something this week as well. Right. So let's look at this week's topic. So this week we're gonna look at what is a finite state machine, FSM, and why would we want to use an FSM in our games. And then I've actually written some code in the player script, and we're just gonna run through the player script and understand how to implement an FSM in Godot. After that, we're gonna start coding and implement the enemy as FSM. Right. So let's look at the final result of this week's workshop. So you can see the player can walk around and attack as usual, but I've added a combo attack for the player. So right, if you press attack very quickly, you're gonna enter this the next stage of the attack, and there's a combo going on. So my inspiration is from some of the mobile games I play, right? And you can see that the goblins are chasing and navigating to the player as usual. And after they are close enough to the player, they are gonna start attacking, right? While they are close to the player, they are gonna continue attacking. But the player is actually able to interrupt this attacking by attacking them, by attacking them. And yeah, so basically, each I have added those different states to the players and the goblins, and they're gonna transition between the states very smoothly, whether they're attacking, whether they're preparing for an attack, and when they are hurt, they are knocked back a little bit, and then they transition back to idle state and then start attacking again. Right. So that's this week's topic, and so for starters, let's understand what is a finite state machine. So an FSM is very simple. It's just a model about the logic of state transition in your game, right? And there is going to be a current state, one and only one current state that your character is currently in. And there will be some events that trigger an action, and the action is called state transition. So in the event of some trigger, and your character is gonna transition from one state to another and do something different. For example, you can see the diagram here. This is an FSM of a very simple FSM of a dog, right? And yeah, it's just has these three states of sits, barks, and wagtail. And these are the triggers. And in the event of seeing a squirrel, it's going to bark. But as the owner of the dog, you can pet it, and then it's going to enter the wagtail. And you pet it further, and then it's going to sit. Yeah, that's very simple, right? And note that you can have some conditions, some checking conditions, um, for the same event. There could be transition to two different states based on some conditions. Let's say when the dog is happy, it goes to sit state. But when the dog is unhappy, if you check that the dog is unhappy, it goes back to the bark state. Yeah, so why do we need FSM in our games? There could be many reasons, and these are some of my personal takes. So first thing first, you can probably see that this presents you a clear logic of your character, right? With an FSM, it's easier for you to think about the logic using states. If you don't have an FSM, all you're gonna have in your code is a bunch of if-else statements, and I believe we don't like to use all those conditional branches to think about the logic. it's easier to think about what state your character is currently in and how does it transition to another state. And it's just easier for you to design the character and all kinds of actions and events that the character can experience, right? And then with an FSM, you can easily define the triggers and the conditions and the actions that your character does when it exits or enters a state. We'll look at this in detail later, but just keep in mind that it makes all these processes very easy, right? And of course, you have less booleans. I remember when I first coded the first platformer in my life, I have all those boolean values flying around, like is player attacking, is player climbing, is player jumping, all those kind of boolean variables. But with a state, you can have less booleans flying around because all those can be how to say summarized into a state. You just have to do the condition checkings on the states instead of all the different branches structured because of the Boolean variables, all those different branches, different permutations of the Boolean variables, which is gonna be very long and very bug prone as well, right? So you have a clear logic and it's easier for you to code out your game. And for one other reason, I love FSM because it provides a single source of truth for your character, right? Because FSM, it ensures there's only one and only one state at a time. So imagine you want a character who cannot attack while it's jumping, right? It cannot have the both jump state and attack state at the same time. Then with FSM, you can easily ensure that because it can only transition from these two states, but cannot have both states at the same time, right? With if not FSM, you're gonna have a many Boolean value checkings, as I said just now, right? Because there's a single source of truth, there will be less bugs. So the behavior is gonna look more natural, and wouldn't be any weird behaviors because you forgot to check a condition. And yeah, by ensuring there's only one state at a time, and each state, the appearance or how to say the actions that can happen at this specific state, right? Is well defined. Then you can ensure that it doesn't look weird, basically, right? Okay, so yeah, that's pretty much about why we use FSM is in our game. And yeah, we're gonna. So this is a very simple player FSM that I have drafted. So if you look at this diagram, I believe it's quite self-explanatory. So the player has these circled states, right? Run state, idle state, and there's attack one, attack two, and attack three states, and there's a hurt state. The arrows represent how the state transition from one to another, and these words describe the events that trigger a state transition. Right, so let's try to understand this diagram first, and you can see this part. There's a run state and idle state, and the events that switch between these two states will be moving and not moving. So basically, when the player presses any input buttons that tries to move the character, it will go from the idle state to the run state. And then when the player stops pressing those buttons, it's gonna transition back to the idle state, right? And so while the player is running or idle, actually I should write a press attack button, right? So it can transition from these two states to this attack one state. So when the player tries to attack and it happens to be in one of these two states, it's going to deal this attack one, the first part of the combo attack. And from the attack one, if the player presses the attack button very fast in a very short time period, then it's going to take this as a combo trigger and then go to the attack 2 state, and then so on and so forth. So you can go to the attack 3 state. And at the end of these attacks, if there's no combo, right, it can go back to the idle state. So this F here just means finish. I lazy write the entire word. It means finish. So the player can, after the attack 1, attack 2, and attack 3 states are finished, it should go back to the idle state. And this particular hurt state is more interesting because it can happen, the trigger can happen at any other state. So from any state, when you take a damage, it will enter the hurt state. And similarly, when the hurt state is finished, it can go back to the idle state. All right, so you can see that this idle state is like the center of the universe. It's like the home state that every other state is referring to, and you go back home when you finish other states. This is like a default state of the character, and from this state, you start other states. So you can see that when the player wants to run, but is in other states, is currently attacking, or is currently being hurt, the player cannot run. It has to finish other states, go back to idle state, and then start moving. It will go to the run state, and it's similar for other states. So this default state provides kind of a clear logic of how do you do state transition, how do you naturally transition between these states. And I believe this is the most important takeaway for this workshop, the how to master using this idle state. Okay, so with this logic in mind, let's go to the Godot project. And first, we'll try to understand this implementation of player FSM. All right, so maybe before that, let me describe what I have added to the player node. So the player node now has 3 attack hitboxes, each with a collision polygon. All right, and these polygons correspond with the collision shape of each attack. So if you look at this attack 1, right, it's from top to bottom, and this area in front of the player is the collision shape. Similar for attack 2, which is the from bottom to up, and attack 3, which is the round attack. All right, and in the script, I have defined these 3 variables that refer to those collision shapes, which we're going to use later. All right, there's also a timer here, and I'll explain it later. So let's look at this code. So yeah, this is where we define the player states. So we will use an enum keyword in Godot. So we enum player state and then a curly bracket, and these are all the different player states that we can define. Now, this enum is basically assigning these names as constant integers. So this is actually 0, 1, 2, etc. State 0, state 1, state 2, etc. But we give them a name that we can refer to, and it's gonna make it very clear later. So we can, if we want to access the idle state, we just do player state dot idle. Right. So behind the scene, this is just 1. Right. This will be resolved to 1, but this is just a clear name for us to use. Okay. So already there is a state variable of the player state type, and then we define it to be the idle state. That means when the game starts, the player is in idle state, right? And this may look new to you. So this is called a setter function that Godot provides us. So this syntax colon set equals set state, and this set state is actually one of the functions later. The name of this set state function. This means we define the setter function for this variable to be this set state function. And the effect of this line is that whenever we set the state variable again, like we assign another value to the state variable, like let's say we say state equals player state dot run. Instead of just assigning that variable, it will actually call this set state function, right? If we say state equals player state or run, it's equivalent to calling set state bracket player state or run, right? So on top of just assigning the new state variable, we can define all the other stuff that happens together when we assign the variable. So you can see here that uh, this is the current state. So I record this current state as the previous state, and then I assign the new state to the state. Right. This is the assigning step, but all other stuff is extra. And so this here we can define all the events that happen once and only once during a state change, right? It's when you change the state, when you set the state to something new, right? This function gonna be called once, and then this will be executed. So right, and you can see that here I match the previous state, and I'll explain the match statement later, but you can just think of it as I'm doing something. I'm making the player perform some actions when it's exiting some state. Okay. So according to the previous state, it's gonna do some actions, right? When it exits a certain state, it's gonna do some actions. And here is when it's entering a state. When the new state is one of the states, then it's going to do some actions. And these actions is just gonna do once when you assign a new state. Okay, so that's why we use this setter function, right? So I mean, it's the same if you call the set state function every time when you set a state, but this just make your code shorter, right? You can just assign the state by this kind of syntax. All right. So yeah, these are some variables that I said just now, and there is a timer as well. So previous attack state timer. Okay, so let's just go on first. So okay, remember that previously we just get the player input and calculate the velocity there, right? But here with all these new states, right, we have a new way of dealing with these inputs. So we first get the x and y directions, right, from the input. So we check that if the state is the idle state, and so this just means if there is any input the player is trying to move, then we transition from the idle state to the run state. And vice versa, if we are currently in the run state and there is no input, there's no movement, then we go back to the idle state. So these four lines will capture this logic of transition between the run and idle states. Okay? And remember that we will only allow the player to move when it is currently in the run state. Okay, so there's a checking that if currently the player is running, if it's in the running state, then we will deal with all the velocity and the flip h, etc. Okay, so this will only happen in the run state. And if it's not in the run state, if it's in any other states, right, we will make the character passively stop with a fiction using this loop function, right, which will interpolate between the current velocity and the zero velocity with this weight, this factor. So this is for, as you probably seen just now, right? When the player attacks, but when the player attacks while it's still moving, right? There's a slight displacement together with the attack. So this is a result of the loop function, right? It gradually stops passively when it's in other states. And I think it's really cool that you can have a small displacement while attacking. Right? It makes the player experience better, in my opinion. All right. Anyways, here's also some new stuff, and this is when I try to flip the collision shape, the tree collision shapes when the direction changes, right? Because in Godot you don't have this flip H property for the collision shifts or for the error 2Ds. So a smart workaround is just to set the x of the scale to be -1, which means you scale it in the opposite direction, which is equivalent to flipping this collision shape, right? It's just a small detail, right? And okay, so this is, let's go on first. Okay, and right, and this is regarding the player's attack. And if the player presses the attack button, and remember that in our diagram, you can only attack when you are in the run and idle states, right? You can only transition to this attack one from this run state or this idle state. So we are going to do a conditional checking here that if the state is not one of these two states, we're going to return. We're just going to ignore the attack input. But if it's one of them, then we're going to let the player attack. Okay, so right, let me explain that I have this variable called previous attack state that temporarily record the previous attack. So if there is a previous attack state, then it's going to level up the attack to be the next level of the combo, right? You can see that it levels up from attack 1 to attack 2, from attack 2 to attack 3, right? But if there is no previous attack state, then it's just going to enter the attack 1, the initial of the combo. All right, so this syntax is the match syntax, the match keyword in Godot. This is similar to the switch keyword in some of your other programming languages like C or JavaScript, right? So you match a variable, means that you check the value of this variable with all these candidates. So if this variable has the same value as this candidate, then it's going to enter this branch, right? If it's the same as this, then it's going to enter this branch, right? And this one, this means default. This single underline means default branch, right? If it's any other branch, any other value, then it's going to enter this branch. So this is just a shorthand for a few if-else statements, but it's quite clean. And also a difference from your other programming languages is that there is no break keyword. In some of your other languages, you have to provide a break here. After this, you have to break it. Otherwise, it's going to go through this right, and it's going to perform both these and these two branches. But in Godot, it's different. There is no break keyword, and then each branch is independent. So it's not going to go through this first branch if it reaches here. Basically, it's just if else statements, right? It can only enter one and only one branch. Okay, so this is a match, and we usually use the match keyword for FSMs because there are many states that we need to check, right? And it's easier for us. It's easier than if else statements to use this match keyword. Okay, so these are all the state transitions in the physics process itself. All right. Okay, let's move on. And there is a take damage function that just takes the damage from the enemies, right? And maybe it's worth mentioning that there is a short knockback function that I designed. So yeah, you can try to understand it yourself. Basically, it gets the direction from the source and then times the knockback distance. So it's going to temporarily change the velocity. And then also remember there's a loop for the velocity. So it's a very small displacement, right? And then there's a transition from any state to the hurt state. Remember that in our FSM, you can go from any other state to this hurt state whenever you take a damage. So yeah, so the take damage function will just simply change the state to the hurt state. Okay, so now this is the most important function of this program, the set state function. And recall that this function defines all the actions that happens once when you exit or enters a new state. Let's look at this one. Yeah, as I explained, it records the previous state and then sets the new state. Then it matches the previous state. So it checks whether the previous state is one of these states. If yes, then it goes to this branch. So this is equivalent to the actions that happen when you leave a state, right? So let's see if the previous state is one of the attack states, then the character is gonna disable its collision shape for that particular attack, right? If you exit the attack one state, right? If your previous state is the attack one state, then it will just disable the attack one collision shape, and so on. And for each of these attack states, when they leave the attack state, there is a function call to the record temp previous attack state. Right, let's check this. Right, basically, the way I implement the combo attack is that there is a previous attack state variable, and when you leave an attack state, it's gonna assign this previous state to this variable as a record. But this record should be temporary because we want the combo attack to only happen when the player presses very fast. So that's gonna be a timer that starts at the same time you call this, right? So when this timer times out, the previous attack state timer, when it times out, it's just gonna clear the previous attack state, which means setting this previous attack state to any default state, like the idle state. Okay, so this will ensure that there's a temporary record every time you attack, and the record gets cleared after a very short period, which I believe is 0.2 seconds. Yeah, after 0.2 seconds, it only preserves for 0.2 seconds. So if within this 0.2 seconds, you have this previous attack state being one of the attack states, then it's gonna continue the combo attack as we have defined here. All right. Okay, so that's for the attack states. And then, okay, so maybe you don't understand this right now, but there is an edge case when the player is damaged while it's in the attacking state. Okay, so this is just how do you say, just to handle this edge case, right? So there was a bug that if the player is attacking and then is damaged by the enemy, the collision shapes are not disabled properly. Maybe after this video, you can try to figure out why this bug happens. But while I was debugging, I find this, and then I just added this to disable all the collision shapes when you exit the hurt state. Okay, it's just a double safe kind of mechanism to just keep disabling the collision shapes in case some bug occurs. All right. Okay, so now we match the new states, which is the actions that we take when we enter a new state, right? And so we match this with all the different states, right? all the 6 different states here. And whenever we enter a new state, the first thing we do is just to play the respective animation in the animated sprite. You can see that in each of these branches, when the player character enters a new state, each of these new states is gonna play this respective animation. And other than that, there are some additional work for some of the states. Let's say the idle state. When you enter the idle state, maybe you want to set the velocity to be 0, right? So it doesn't have the friction as in other states. And in each of the attack states, we will enable the collision shapes with this line. So there's one-time action that it enables this collision shape by setting this disabled property to false. Okay, so these are the actions, right? These are the events that only happen once during a state change. Okay, and I believe that's pretty much all. And this one, there is one other signal that I have defined here. So remember that there are four states, one, two, three, four. These four states that have this trigger called finish, right? So this state will transition back to the idle state only when they finish. So there needs to be a mechanism to check how they finish. Like when they finish, there should be some kind of signal that tells you that it has finished. So the signal I chose is this on sprite animation finished. It's uh it's in the sprite node. Sprite node, there is a signal called animation finished, right? So it just means that if there are some of the animations that is not looping, then after it's been played, after all the frames are played, then it's finished. So this function will be called. All right. So when the sprite animation is finished, we will check if the current state is one of these four states. If it's one of these four states, then this should be a finish trigger, and it's going to move back to the idle state. Okay, so just a note, just something to note here is that with this, we have defined the duration of the state to be the duration of our animation, right? So maybe it's worth noting the duration of your animation. For example, this one has 4 frames and 8 frames per second. So this state will last for 0.5 seconds exactly. And you want to synchronize that with all other time variables that you might have in your game, right? It's just some minor detail that you should pay attention to. Okay, so the remaining are just with the attack collision shape, the attack hitbox, right? And it's just gonna deal the damage to the enemy body. Okay, so this entire script has captured all different logic in this FSM. I hope that it is clear to you that uh, it's clear to you how this implementation has fulfilled all the different transitions and triggers and conditions in this FSM. All right. So having seen this, I hope you have a better understanding of how to implement an FSM in Godot. So now let's get our hands dirty to implement an FSM for the goblins. Okay, so let me just quickly go to this goblin FSM here. A goblin is quite simple. They only have 5 states, so this is a run state and idle state similar to the player, but we don't control the goblins. They just navigate to our player. So different to the player, there's the triggers are different for the transition between these two states, and they will be whether the goblin has finished their navigation or not, or that it is currently still navigating, right? Then it's going to transition according to the navigation result. Okay, so while the goblin is in the idle state, it should start a cooldown timer for the attack, right? And when the cooldown timer is time up, it will transition to the casting state. Casting just means when the goblin is preparing the attack, right? When it's holding up its sword and just about to attack. So that phase before the attacking phase is called the casting state. And then in the casting state, there will be a casting delay timer, right? So this is the duration that it uses to cast the attack. And then after this timer is finished, it's going to transition into the attacking state. And similar to the player, when it finishes attacking, it will go back to the idle state. And then you can kind of see that there is a cycle going on here, right? So it's gonna continue the cycle of being idle and casting an attack after cooldown and dealing the actual attack after the casting delay. and go back to the idle and so on. It will continue this cycle forever as long as it's still in the idle state. But if it gets interrupted because it's navigating, then it's going to go to the run state. This is quite natural, right? Because it's only in the idle state when its navigation finished, meaning that it's very close to the player, then it's gonna enter this cycle of attacking. But once the player runs away from the goblin, it is no longer within the goblin's reach, then it will start navigating and go to the run state, which ends this cycle. All right, and similar to the player, at any time from any other state, if the goblin takes the damage, it's going to enter the hurt state. And when the hurt state finishes, it goes back to the idle state, and then either starts running or starts the attack cycle. Okay, so this will be the Goblin FSM, and we will now be implementing this simple logic in our game. Okay, maybe before we start coding, let me just explain the goblin scene that I have updated. Right, so the goblin, you can see there are a few animations in the goblin sprite, right? Idle run. Then there is a hurt animation, just like the player has. And also there is a casting animation, which is the phase before attacking when it's holding up this torch, and then the actual attack, right, when it strikes this torch. And similar to the player, the attack hitbox has a collision shape, and it is accessible in the script here. Right, this attack collision variable. And it also has the two timers that I described just now, the cooldown timer and the cast delay timer, which is also accessible here. Okay, so let's start coding. And our first step will be just defining these five new states to the goblin. And we just use the same enum keyword as before. So we enum goblin state and bracket, and we put in the name of the 5 states. So idle, run, casting, attacking, and hurt. Okay. And then there is an onReady variable state. We can specify it to be of the type goblin state, and its initial value can be goblin state dot idle. So we set the setter function :set equals the set state function below. All right. So similar to the player, whenever we set the goblin state, it's going to call this set state function, which I have already defined here. Okay, so after that, let's code the logic. Right. So before this workshop, the last workshop, what we did is checking if the navigation agent has finished navigating. If yes, then we just return from this physics process, and the goblin will no longer move. Right, but now we have a new tool to do this, which is the difference between the run state and the idle state. Right, so here we can transition between the idle state and the run state based on this is navigation finished result, just similar to the player. Right? So we can first check if the current state is running state. Right? So if state equals goblin state dot run, and the navigation has finished, then we transition to the idle state, meaning that the goblin has reached the player. So state equals goblin state dot idle. But else, if the state is currently in the idle state and the navigation result is it hasn't finished yet, so and not navigation agent dot is navigation finished, then we can set the state to the run state. Goblin state run. Okay, so these 4 lines handles the transition between the idle state and the run state. All right, so now we have this run state and all this logic of calculating the next position in the navigation and setting the velocity and so on will only happen in the run state, right? It's going to be allowed to run, to move in the navigation direction while it's in the run state. So we need to add a conditional checking here. If the current state is equal to goblin state dot run, then we indent these lines by 1 tab, right? It's only going to enter this running logic while it's in the run state, right? And similar to the player, we also want it to have the knockback and other passive stopping with friction kind of functionality, right? So here we can else in any other states, then it can have the same lerping velocity. So velocity equals lerp of the current velocity to vector 2.0 with a weight of 0.1. Okay. Right? And move and slide after that based on the velocity that you get from different states. Right? So this is a physics process. Okay? Right. Now let's go to, okay, let's look at all these functions that I have added. These are from last week's navigation workshop. And this one is the new take damage function. So it's quite similar to the players, right? There's a knockback here. And there's something to do here, which is to transition to the hurt state. Anytime that it gets damage, it should set the state equals to goblin state dot hurt. Okay, so that's for taking damage. Right. So now let's do this. Let's do the most important function for this script, for this FSM, which is the set state function. Right. So here, as usual, we have recorded the current state to this previous state variable and updated the state to be this new state that we have set. Okay, so now let's do the events that only happen once during the state change, including exiting a state and entering a state. Okay, so here let's do the events that happens when we exit a state. So remember that we should match the previous state, colon, right? And these are the events that we should do. So first event is disable the attack collision shape when it's exiting the attack state. So if the previous state matches with the attacking state, right? So it matches with the goblin state dot attack. See, attack or attacking? Let me check. Attacking. Goblin state dot attacking. Right. Then we're gonna set the attack collision disabled property to be true, meaning that we disable the collision shape and it's no longer gonna be able to hurt the player. Right? And also when you exit the hurt state, the bug, the edge case is also present here. So let's just add goblin state dot hurt. Then similarly, we should disable the attack collision. Okay, that's it for the events that happen when we exit these two states. And for entering a new state, we should match the new state. All right, so when you enter the idle state, right here, remember that whenever you enter the idle state, meaning that you are close to the player, you should start this cooldown timer and prepare for casting. Okay. So if it's goblin state or idle, you should do attack cooldown timer dot start. Just start the timer for attack. Okay. And oh, I forgot to mention that similar to the player, all the animation logic should be moved here. So you should play the respective animation for that state whenever you enter a new state, right? So for entering the idle state, we should do the sprite dot play idle. Okay, so that's for idle state. Next one will be casting state, or maybe we do the run state first. So for golden state or run, right? There's nothing else to do other than playing the sprite. Sprite dot play run. Okay, and now we do the casting state. When it enters the casting state, casting, right? Remember that we're gonna start the delay timer, the casting delay timer here. Right, so just attack cast delay timer dot start. And also sprite dot play casting, attack casting. Right? Next one will be the attacking state, the goblin state dot attacking. Remember to enable the collision shape so that it's going to damage the player for while it's at this attacking state. So attack collision dot disabled equals false, which means we enable this collision shape. All right, last one will be the hurt state. So goblin state dot hurt. Also, also for the attacking state, we should play the attacking animation. And for the hurt state, we play the hurt animation. Okay, so that's it for the events when you enter these new states. All right, let's move on. And all that are left are the signals. So, okay, so remember from last week's workshop, there is this signal on navigation agent 2D velocity computed. This is connected with this navigation agent 2D that while it's avoiding an obstacle, it's going to compute this safe velocity and provide this to this function of this signal that there is a safe velocity that you can use to avoid the obstacle. But right, we handle that by directly setting the velocity to be this safe velocity. But now we have different states, and it should only be able to move in the run state, right? So be careful that we need to update the code here by checking if the current state equals goblin state or run, then it's able to set the velocity. Whilst in other states, we just simply ignore this safe velocity. All right. Okay, so this part is for the states that should end after the animation is stopped, similar to the player, right? There are two states that the attacking states, the attacking state and the hurt state that is only triggered when they are finished and it goes back to the idle state. And we handle this similarly by connecting the animation finished signal to this code. All right, this is okay. This is when I coded this out and then it appeared here. So let's just first disconnect this one, and then double click on this animation finished on the sprite node, animation finished. Then we connect to this code. Okay, let me just move this up to this place. Okay. So when the sprite animation has finished, we first check if the current state is one of these two states that should finish. So we can do that by if state is in this list of two states, goblin state dot attacking and goblin state dot hurt. If it's one of these two states, then we simply set the state back to the idle state. All right, so this will handle the transition from these two states back to the idle state, and the duration of these two states are similarly defined by the duration of your animation. Okay, so now for the two timers, right? The first one is the attack cooldown timer. We will transition to the casting state, right? When the cooldown is time up, the goblin is prepared for the casting the attack. So we can simply set, oh, okay. So if we set the state be goblin state dot attack, there could be a problem, right? So if we simply do this, there is a slight problem. Maybe you want to think about it for a moment here. Okay, so the problem is that we want to handle the case that the goblin is idle and is preparing for this casting while it's being hurt and interrupted by the player, by taking damage from the player. All right. So even if it's hurt, the timer is still here. And when the timer times out, this is still gonna be executed and it's gonna enter the attacking state. So it doesn't look natural when you interrupt the goblin and then suddenly it goes to this attacking state, right? So here we should perform another conditional checking if the current state is equal to the idle state. If it's still in the idle state, if it's still ready to attack, right, then we set the state to be the attacking state. All right. Now this is the condition that I mentioned before, right? So if you can have this foolproof condition checking that it is still ready for attacking while this timer has timed out. Right, and for the cast delay timer, we can similarly first check if it's still in the casting state. If the state is equal to goblin state dot casting, if it's still in the casting, then we can set the state to be the attacking state. Okay, I made a mistake here. This one should transition to the casting state instead of the attacking. So idle to casting, casting to attacking, and attacking back to the idle. Right, I hope you can see the logic here. Okay, I believe we have completed all the to-dos. So let's just check if the game is working as intended. Right. So if I attack the goblin, it's gonna have this knockback, right? And then while it's still casting, it's going to be interrupted, right? And then go back to the idle state and then keep running because navigation is not finished. And if navigation is finished, it's going to be idle, just stop there, and then enter the cycle of attacking the player, right? You can see if I stay close to them, they just keep attacking unless I walk away, and then they're gonna start running state. Okay, quite cool, right? Okay, right, and I hope you can also see the connection between this script, between this implementation and the diagram we have here. Actually, it's not a requirement, it's not mandatory for you to draw this diagram, although it helps for you to draw this. I always draw this when I develop a new game, but you can also have this mental picture of the different states and different transitions, and then while you are coding your game. And I hope that you find this a quite useful tool, a useful mental model to have in order to have a clear logic of different transitions. And that with the correct implementation, you can see that the transition between different states are quite natural due to the fact that there is only one state at a time, and the fact that there's a default state that every other state goes back to before deciding the next state. Okay, right. That's the end of this workshop, right? So this week is finite state machines, and we implemented an interesting enemy FSM, right? So I wouldn't say it's a very smart kind of enemy, right? It's only natural yet. So, right, we make the state transitions quite natural today. And then the the different actions of the enemy are quite normal or natural. Just saying that it's not yet able to make all those decisions, but it's able to passively transition between all these states according to some triggers and conditions, right? I hope you find this workshop informative and useful in your game development. And next week, we are going to look at boss design, right? We're going to have a bigger FSM for the boss while it's actually able to make decisions based on some factors. All right. So stay tuned and hope to see more of you coming to the physical venue next week. Thanks for watching this recording. Bye bye.